Today's lesson is on molecular compound nomenclature. In this particular lesson, we will first start off by looking at the definition of a molecular compound and why it is different from the ionic compounds from the previous lessons. We will then realize that we will need to use prefixes, so we will look at the different prefixes and what they mean. And finally, we're going to use a little simulation to show you how you can determine the names from formulas and the formulas from names as we have done with the previous examples. Now, before we start, we must recognize that a molecular compound is different from an ionic compound, and that molecular compounds are formed from two nonmetals. Now, because they're both formed from nonmetals, what is going to happen is that, unlike the ionic compounds, where one atom passes an electron to the other atom, and therefore they share a bond in that way, these guys are going to share electrons. And because they're going to share electrons, they can actually form in a whole bunch of different amounts rather than the simple ratios as predicted by an ionic compound. So because they all would like to get electrons, neither one is willing to part with their electrons. So again, they determine convenient ways to share, and they can be done in just about any possible ratio with any amount of either atom. So since we're not going to form ions to do this, we're not going to use the crisscrossing method as we did before. The names are still going to be done the same in that they're going to end in IDE, but because it can be any ratio, we can't just simply say something like lithium oxide, for example, to indicate lithium and oxygen, because they can be in any proportion, so it wouldn't have a simple ratio to determine from the crisscross. So instead we will use prefixes, and these prefixes are going to be used to indicate the amounts of each type of atom that got involved in this interaction. Now, the only rule when we look at the prefixes on the next slide that you'll have to keep in mind is that when we use the binary nomenclature system here, you're not allowed to use mono on the first word. You can use mono on the second word, but the prefix mono is not ever used on the first word in the nomenclature. All right, so what we have here are the prefixes that will be used in this naming system. For example, if you have one of a particular atom, you will use the prefix mono, but again, keep in mind that is only on the second element. If you have two of any of the particular elements, you would use the prefix di. If you had three of any particular element, you would use tri. Four would be tetra, and so on if you read through the list. You may decide at this point that you want to pause this and copy these down or print something from the internet so that you have this in front of you to see what we're going to do next in this. Okay, I am in Inkscape at the moment, and what you will see here is I have a couple of different formulas that are listed and a few names that will be used to make these formulas. So you will first see that I have N3S5. I'm going to pull this down a little bit. N3S5, first of all, if we look, it fits the criteria of what we were talking about for molecular compounds. There's nitrogen, a nonmetal, and sulfur, another nonmetal, and these guys are going to form a molecular compound. Now, if you look here, the charge values that would have been associated with these, N's -3 and S is -2, when they crisscross, they wouldn't give you these two numbers. So we see that automatically the crisscross is not the correct way of doing this. So what we need to do is indicate the amounts of each of these nonmetals that are in the formula. So the first thing we need to do is recognize the two names. We have nitrogen and we have sulfur. These are the two participants in this particular compound. Now what we will notice here is that we had 3 nitrogen. So the way we're going to designate that we have 3 nitrogen is to change the prefix here to indicate that. So we're going to turn on the typing tool here. And the number 3 is indicated by a prefix of tri. So because we have 3 of them, we're going to have tri-nitrogen. Now notice I didn't change the word nitrogen, I just put a prefix in front of it. Now sulfur, we do need to change the ending because the same rules still apply in naming the second word, and this will become sulfide. But because I have an amount that's specified in this formula that's not done by crisscross, I need to use a prefix, and 5's prefix is penta. So this would be pentasulfide. And our total complete name here would be tri-nitrogen pentasulfide, meaning I have 3 nitrogens and 5 sulfurs attached to one another. And that would be how we do our first one. Okay, I'm going to delete this. And now we're going to choose another name. So we'll look at this guy here. We have SiF3. Okay, if you look at SiF3, it still fits our criteria of having, whoops, I'll put on my moving tool, sorry. It has the criteria of having 2 nonmetals. We have Si, silicon, and F is fluorine, both nonmetals. That means we will use the prefix method of doing this. So we're going to bring silicon down. This is the name of our first element, silicon. and the F is fluorine. Okay, now again, the next step that we need to do is use prefixes to indicate how many of each we have. So because we have only one silicon, the first thought would be to put the prefix mono in front of it. But we cannot put mono in front of the first word, so we're not going to do that. We're just going to have silicon. It's going to indicate that we have one of them. But fluorine has 3 of them, so we do need to change that one. So we're going to turn on our typing tool and change the ending from fluorine to fluoride. And we're going to indicate that we have 3 by putting the prefix tri in front of it. And this name is just very simply, for SiF3, it is silicon trifluoride. Okay, and that's how this would be named. All right, so we've now named a second one. Again, notice the rule was that you do not use mono on the first word. Okay, so we're going to delete this guy. Whoops. Get a little better aim here. All right, our final one that we have here is the only guy that's left, which is CO. And as we can see here, C and O are made up of carbon and oxygen. They both fit the criteria of being nonmetals. We have C and we have O, and we have one of each. So if we follow the rules that we've already used, we have one carbon, and in the first word, we do not change the ending of it, and we put prefixes unless it's mono. And this is mono because there is one, so we don't do that one. So it stays carbon. And the oxygen, we need to change the ending to IDE like we said we did before. So oxygen becomes, okay, I'm trying to turn on the typing tool. Oxygen becomes oxide. And because there's only one, we said that you will use the prefix of one on the second word, but not on the first. So this becomes monoxide. Now, if you were to read this, this looks pretty terrible. That looks like monoxide, and we don't want to use a double O here. So instead of doing that, it looks a little bit better to take the O away, and this would be carbon monoxide, something you have probably heard about in your house. It's not something you want to have. It is a poisonous gas, but this is carbon monoxide. One carbon, one oxygen, and this is letting us know that, again, this is a molecular compound. All right. In the final part of this lesson, we are going to now look at how you determine the formulas from the names of these compounds. So for example, if we look here, we have carbon dioxide. We see in the name carbon and we see oxide. That's indicating that we have 2 nonmetals. Now we do see a prefix of di used, meaning that we have 2 of these oxides. So very simply, we just name it from the prefixes. So if we have carbon with no prefix, it means we have 1 carbon, and di means 2, so we have 2 oxygens. So this formula would be CO2, 1 carbon, 2 oxygens. Okay, on our next example, we see trinitrogen hexafluoride. Again, the keywords here are nitrogen and fluoride. That means we have N and we have F, both nonmetals. And we do have 2 prefixes. Tri means 3, so I have 3 nitrogens. And hexa means 6, so I have 6 fluorides. So if we look here, N3 stands for trinitrogen, and F6 stands for hexafluoride. N3F6 will be our formula. Finally, in our last example, diphosphorus pentabromide, we see that we have 2 nonmetals, phosphorus and bromine, and that means that we have 2 prefixes. So we have 2 phosphorus and we have 5 bromide. So our formula will be P2Br5. Okay, hopefully you learned a little bit about molecular nomenclature. Please make sure to refer to the notes on the website and take the required online quiz that goes with this lesson. And be sure to bring any questions that you have with you to class.